So example 4 is quite unlike anything we've already seen before. It's an exponential equation of the quadratic form. Well, it certainly doesn't look like a quadratic form, so let's maybe think about how I would go about solving this. If we think about what we did earlier, we would try to isolate one of these, and if we did so, we would maybe move this over and try and take the natural log of both sides, but we did that in order to get the x out of the exponent, and that's not going to work here. So what I'm going to do is kind of look at each of these numbers. I see a 64, and I see an 8 with x's on it. Well, that's interesting, because I know that 8 squared is equal to 64. Maybe this is where the quadratic form comes in. So if I'm going for a quadratic form, what I'm going to do is need to isolate, or I'm going to have to get 0 on one side. So what I'm going to do is I'm going to add 100 to both sides. So I have 64 to the x minus 20 times 8 to the x plus 100. I'm going to set that equal to 0 now. Now I'm going to use what I said over here, that 8 squared is equal to 64. Seems very much like that first example we did. So that turns this into 8 squared to the x. And that would be equal to, or not equal to, but minus 20 times 8 to the x plus 100 equals 0. Now what I'm going to do is think about this in terms of power to a power means I can multiply. I can multiply in any order, so I can write this as 8 to the x. Ooh, now we're getting somewhere. Squared minus 20 times, here's another 8 to the x plus 100 equals 0. Now this is something that we're going to do a lot as we get into calculus, is we're going to just turn this into something else we can deal with by making a substitution. So let y equal to 8 to the x. And I just chose y as another variable. And I'm going to go ahead and solve for this new variable, because I can easily solve this expression, but let's see what happens when I substitute. So wherever I see an 8x, I'm going to write y, so I get y squared minus 20 times y plus 100 equals 8. This is exactly a quadratic function in terms of y. I can solve this like I would any other quadratic function. So, what are the factors of 100 that add to negative 20? Well, that's just negative 10 in itself. So y minus 10 equals 0. So this is y minus 10 squared equals 0. Or you could have just thought about it however you wanted to think about it. Y is equal to positive 10. So, is that our solution? Not quite. That'll help us to work with this expression. So what I now need to do is now solve for my original variable, solve for x. So in doing that, y is equal to 10, so 10 is equal to 8x. Now I'm going to take the natural log of both sides, so ln of 10 is equal to ln of 8 to the x. Power rule says the x could come down, so I have ln of 10 equals to x times ln of 8. Again, dividing 8 by both sides, not just 8, I need the ln of 8. I find that x is equal to ln of 10 divided by ln of 8. Side note, maybe haven't encountered this too much yet. Can I simplify 8 and 10 to the 10? They're both divisible by 2. Not here, because remember, this 10 belongs to this ln first, so you can't do any sort of cancellation between the numerator and the denominator. Of course, you could type that into a calculator, but we have solved this in terms of ln, and we have our solution.